This is lessons 11.1 and 11.2. The circumference of a circle is the perimeter of the circle. So we can use two different formulas depending on if we're either looking for or have the radius or the diameter. So the circumference is either 2 times pi times r or pi times d. So we want to find the radius of a circle whose circumference is 121.27 feet. So if c equals, we're looking for r, so 2 pi r, I'm going to take 121.27 and set that equal to 2 pi r. I would recommend dividing in separate parts because if you try to divide all at once, you need to use parentheses. So like you could divide by 2 first and then divide by pi on your calculator, and there is a button on your calculator that is the pi symbol. So if we do 121.27 divided by 2, I'm just going to write out the whole thing. And now I could divide by pi, and I get 19.3 feet. It should work on some calculators if you tried to divide 121.27 by 2 pi, but it also might give you a totally different answer, in which case if you wanted to divide all at once, you would have to use your calculator and hit 121.27 divided by, and then parenthesis 2 pi. And then you should definitely get the right answer. So here's a try. We're looking for the diameter of the circle this time. Pause. Answers are posted online. The arc length. So we've talked about arcs, and we've talked about the measure of arcs, measuring them in degrees. But since circumference is a measure of length or of distance, we can also measure an arc in its distance. So the arc length is the distance between the endpoints along an arc measure. It is a portion of the circumference. Since it's a portion of the circumference, we're going to set up a proportion using the ratio of degrees to 360. And then on the other side, it's length of the arc over the circumference of the circle. I didn't put any formula here for circumference. I didn't put 2 pi r, pi d, or c, because it will change depending on what the problem is either giving you or asking for. So for example, 2, we want to find the length of arc zy. We are looking for the arc length. So in our proportion, we're going to have an x in the spot for the arc length. I do know the degrees of arc zy is 130 because that was the central angle. And down here, we're going to have circumference. 10 centimeters, because it's centered on the diameter, is the diameter. It's not the radius. So I'm going to use pi d for my circumference formula. And now I'm going to cross multiply and solve. So I'm going to get 360 times x. 130 times 10 is 1300 times pi. Now I could get a decimal right there, and that's perfectly fine. And for what we're going to do in class, that's exactly what we would do. I would turn this 1300 pi into 4084.07. I'm going to write it down here because I'm going to do something different. 4084.07, and then if I divide it by 360, I would get 11.34. When it comes to our final or any standardized tests, they may have the answer written in exact terms, meaning they're not multiplying by the pi, they're leaving it with pi in the answer. So if I wanted to do that, I would be dividing 1300 by 360 here. And I'm reducing the fraction of 1300 over 360. And that's 65 over 18. So this would really be 65 pi over 18 centimeters. So I just wanted you to see that it can look different than just writing our decimal. This would be the exact answer, and this would be the approximate answer. All right, example 3, we want to find the length of the radius. So we don't know r. So in our proportion, I'm going to use 2 pi r for circumference. I know the degrees of this big arc is 290. And I actually know the arc length, which belongs up here, because they're telling me this length here is 46.75. So when I cross multiply this, 360 times 46.75 is 16,830. And here would be 580 pi r Again, if you wanted to turn this into the decimal right now, I am fine with that because I don't care if we get exact answers right now. So this would have been 1822.12R. And now I'm going to divide both sides by that number. So I get R is 9.24 feet. For example 4, we're looking for the measure of arc RS. So we don't know how many degrees the arc is. So I'm going to put that over 360. I know the arc length here, because it's on the outside, is 44. And then they're showing the arrow is pointing to just this segment here. So that's the radius. So we'll use 2 pi r. And now I'll cross multiply. So 2 times pi times 15.28 times x is about 96.01x. And 44 times 360 is 15,840. Divide that by that 96.01. And we get 164.98, so we'll say 165 degrees because we rounded to get that and all that stuff. So the measure of arc RS is 165 degrees. So here's some for you to try. Pause. Answers are posted online. The area of a circle is pi r squared. So we have to make sure we square the r before we multiply by pi. So let's find the diameter of a circle whose area is 122.72 square inches. So if A equals pi r squared, then 122.72 equals pi r squared. I know I want to get the variable alone, so I'm going to divide 122.72 by pi. I get 39.06 equals r squared. And now we'll take the square root of both sides. So r is 6.25 inches. So here's a problem for you. Hold on. Let's go back a second. Find the diameter. I only found the radius. So I'm going to double this. And the diameter is really 12.5 inches. Whew, that was a close one. Now there's one for you to try. Pause if you'd like. Answers are posted online. Population density is a measure of how many people live within a given area. So we're going to find a density by dividing the number of people by the area we are talking about. And we're going to do this with circular areas right now because that's what we're talking about. So area will usually be in terms of square miles, square feet, square something. So the units for density are always going to be people per square feet or people per square mile. So for example 6, about 430,000 people live in a 5-mile radius of a city's town hall. Find the population density in people per square mile. So our density will be the people divided by the area in square miles, and area is pi r squared. So I'm going to make sure I actually do the bottom first. So 5 squared is 25 times pi is 78.54. And when I divide 430,000 by my answer, I get 5474.93. We're usually not going to write our densities in terms of decimals. We're going to write them as whole numbers. So I'm going to round this up and say about 5,475 people per mile squared. For example 7, a region with a 3-mile radius has a population density of about 6,195 people per square mile. Find the number of people who live in the region. So now, instead of doing density equals people over area, we're going to do that, but we know the density, and we don't know the people. So we're going to find what pi not 3 squared is, or 9 pi is, and just multiply it by 6195. So 9 pi is really 28.27. So when I multiply that by 6195, again, this is people, so we're going to round it. They had 175,159.49. You can round up or down. Either will be fine. So I'm going to round up to the nearest person, 175,160 people. So here's one for you to try. If you'd like to pause, answers are posted online. A sector is a slice of a circle. So a sector is basically when you take an arc and the two radii that bind it, or bound it, that becomes the sector. And just like we can say that the arc is a portion of the circumference, the sector is a portion of the circle. So the degrees over 360 will equal the area of the sector over the area of the circle. So for example 8, let's find the area of the shaded sector. This shaded sector has a degrees of 135. So 135 over 360 equals, we don't know the area of the shaded sector, that's what we're looking for, and we can put it over the area of the circle, pi r squared. My r is 6. So we're going to get 360x equals 36 pi times 135, which is 15268.14. It is also possible to write this as an exact answer. Our final will be written that way. But for our purposes right now, we're going to say it's about 42.41 centimeters squared. All right, example 9, find the area of the shaded sector. 65 is representing the unshaded sector. So the shaded sector is really going to be 360 minus 65, or 295 degrees. So we're going to put 295 over 360 equals x, because we don't know the area of the shaded sector, over pi r squared, and r is 11. So let's cross multiply 360 times x and 295 times 121 pi. And now we'll divide by 360. So we get an area, of 311.4976, so 0.50 or 0.5 inches squared. So here's some for you to try. Pause if you'd like. Answers are posted online. Example 10, find the area of the circle. So the area of the circle, they're giving me the area of the shaded region. That's why they're putting it next to this little sector. So the degrees over 360 will be 40 over 360. And now the area of the sector is 35. And they want the area of the circle. Normally I would have done pi r squared here, but that would have me solving for r, when all I want to solve for is a, the area. So that's all I'm going to put down there. So we have 40a equals 360 times 35 is 12,600. And when we divide by 40, we get the area is 315, and let's include our units, meters squared. All right, example 11. Find the area of the shaded region. So I see that the circles each have a radius of 15. And the shaded region is this rectangular piece without the circles, right? If I filled in the whole rectangle and then took away these circles, that would give me the area that's shaded in. So I know I could find the area of the circles. The rectangle is going to be a little more work. I know this is 15 because it's a radius. This is also 15 because it's a radius. This is 15, and this is 15. So all the way across is 60, because that's 15, 15, 15, 15. And the way across this way is 15 and 15, or 30. So the rectangle is really 30 times 60, because that's how we find the area of a rectangle, length times width. So the rectangle is really 1,800. I have the circles. 2 circles is really 2 times pi r squared. So we're going to do 15 squared times pi, but double it. So the area of my shaded region is going to be the rectangle minus both of the circles. So we get 386.28, and that's inches squared. So you go ahead and try this one. That is actually the end of our lesson. Answers are posted online, and that is the end of 11.1 and 11.2.